Get ready because we are going on a seriously mind-bending journey today, one that's pretty much guaranteed to completely shift your perspective on reality. We're going to be zooming way, way out. We'll start by shattering the illusion of your own stillness, and then we're heading all the way out to the absolute outer edges of theoretical physics. I promise you, by the end of this, you're never going to look up at the night sky the exact same way again. Take just a quick second right now and look around you. You're probably sitting still, right? Your room feels perfectly quiet. The floor beneath your feet, completely motionless. It feels like you are perfectly, solidly fixed in place. But here is the wild truth that science has uncovered. You are not standing still. In fact, you have literally never been standing still for a single moment of your entire life. Okay, let's dive into this. Because at this exact second, whether you feel it or not, you are hurtling through the cosmos at a staggering combined speed of over 2.5 million kilometers per hour. Just let that sink in for a second. 2.5 million. You are, right now, one of the fastest moving objects you will ever encounter. So how on earth do we get to a massive number like that? Well, let's break it down. The Earth itself rotates at roughly 1,670 kilometers per hour at the equator. But, it's also orbiting the sun at over 107,000 kilometers per hour, and our entire solar system, that's orbiting the center of the Milky Way, while the Milky Way itself is basically rushing toward a region of space called the Great Attractor. You add the whole shebang up, and boom, you get that 2.5 million number. So why don't you feel this incredibly violent motion? Well, it all comes down to Einstein's principle of relativity. You are accelerating with the Earth, not relative to it. The cosmos simply has no fixed center. Every perspective is valid, and right now, your specific frame of reference tells you that you're at rest, even while you are absolutely flying through the void. Let's move to and see how this builds as we take a step back. We start right here on our little spinning rock, but as we zoom out, the scale gets almost impossible for the human brain to comprehend. We move past our solar system, out into the vastness of the Milky Way, which, by the way, holds around 250 billion stars, and then out past our local group of galaxies, all the way to the edge of the observable universe. We're talking about a sphere roughly 93 billion light years in diameter, containing literally trillions of galaxies. Because our brains just aren't really wired to handle distances like that, let's ground those incomprehensible numbers with some analogies we can actually picture. If the sun were the size of a standard basketball sitting in front of you, Earth wouldn't be a tennis ball right next to it. No. Earth would be a single grain of sand sitting 26 meters away. Or, if you want to look at it on a much larger scale, imagine the sun as the massive dome of St. Paul's Cathedral in London. In that scenario, Earth would be a little car parked almost 4 kilometers down the road. That is really how tiny our footprint is in all of this vastness. But here is where the sheer mind-numbing scale of reality gives way to a truly deep cosmic mystery. As astronomers started actually mapping all this vastness out, they realized something weird. The universe is not an even, smooth spread of stars like we assumed. It's actually full of massive, totally unexplained holes. And this brilliantly illustrates what I mean. The true architecture of our universe is just fascinating. Galaxies actually clump together in this glowing thread-like structure that we call the cosmic web. But look at the negative space. Look at those enormous dark patches sitting right between the bright filaments. The most famous one is known as the Great Boots Void. It's an expanse of absolute darkness stretching nearly 330 million light-years across. To really understand why astronomers call this thing the Great Nothing, you gotta look at the stats. In a region of space 330 million light-years wide, based on typical cosmic density, we should absolutely expect to find around 2,000 galaxies. But in the Boost Void, we've only confirmed about 60. It's a staggering statistical anomaly. Actually, think about this. If Earth had been placed right in the exact middle of the Boost Void, the night sky would be so completely empty around us that we wouldn't have even known other galaxies existed until our telescopes got powerful enough in the 1960s. Crazy, right? Mysteries like the Bootus Void really serve to remind us of a recurring pattern in science, something we call the Copernican cascade. Just take a look at this historical timeline. In 1543, Copernicus proved Earth isn't the center of the solar system. Then in 1785, Herschel proved the sun isn't the center of the galaxy. Move up to 1924, and Hubble proved our galaxy isn't the entire universe. It's like every single time we thought we had finally found the absolute edge of reality, we were beautifully productively wrong. There's this fantastic idea. Every time a human being has looked up and said, this is everything. They have been wrong. I just want to let that sink in for a moment. The history of science is essentially a history of realizing that the universe is infinitely grander than we ever dared to imagine. Honestly, it is the ultimate lesson in human humility. So, what if we are wrong again right now? What if our universe is just one among countless others? Well, this brings us to the next logical frontier in astrophysics, the multiverse hypothesis. And physics gives us three main theoretical frameworks for how this could work. First, eternal inflation suggests that space expands endlessly, just popping off separate isolated bubble universes. Then you have quantum many-worlds, where every single quantum event literally branches reality into separate parallel paths. And finally, there's the string theory landscape. That one calculates 10 to the power of 500 possible solutions to the laws of physics, with each one potentially representing a completely different universe with totally different rules. To picture what that eternal inflation model might be like, imagine reality as a vast cosmic ocean. And inside this ocean, universes are just being born like little bubbles. Our entire observable universe, all 93 billion light years of it, might just be one single bubble floating in this massive expanse. And the truly crazy part? Different bubbles might have completely different laws of physics. They could have different numbers of dimensions. Heck, some might have no stars or life at all. Now, all of this immediately begs a question that takes us from high-level astrophysics straight into some deeply personal territory. I want you to really think about this for a second. If there are infinite realities out there, could there be another you? Now, what's really interesting about this slide is how it frames the quantum many-worlds interpretation, where reality is actively branching all the time. Every choice you ever made, every fork in the road, whether you studied art or science, whether you took that job, whether you turned left instead of right, it all created a new branch. Somewhere out there, in a different reality, another version of you is living out the consequences of the exact choices you didn't make. And all these paths might actually exist simultaneously. It's a lot to wrap your head around. You are not just one story. You are a multiverse of possibilities. Now, to be absolutely clear, we don't have direct observational proof of the multiverse. There is no telescope that has seen one. But even just as a hypothesis, it fundamentally expands our imagination, doesn't it? It really reminds us of the weight of our daily choices, because each choice is like a brush stroke on this endlessly branching canvas of reality. Okay, let's reel it back in and bring ourselves back to the present moment, back down to our spinning Earth. The truth is, we don't have all the answers. We don't know for sure what lies beyond our cosmic horizon or why those massive voids are really out there. But the pursuit of those answers, the fact that we even know to ask these questions in the first place, is absolutely our greatest adventure as a species. Carl Sagan absolutely hit the nail on the head when he said, "We are a way for the cosmos to know itself." We aren't just tiny, insignificant specks floating around in a cold void. We are made of the ash of ancient stars. We are the universe itself, literally waking up, building telescopes, and looking back at itself in the mirror. Ultimately, the greatest journey isn't across billions of light years. It is simply the journey from not knowing to knowing, from silence to asking questions. So the next time you feel perfectly still, just remember that you are flying through the cosmos at 2.5 million kilometers an hour right now. Maintain that curiosity. Keep questioning the very nature of reality. And whatever you do, keep looking up.